Welcome to the Wolfram Language in Section 9 of Fast Introduction for Programmers. This section is about defining functions, which is typically done using assignments. For example, this defines a function f that takes two arguments. That definition is applied automatically whenever something that matches the pattern f with two arguments comes up in a calculation. Function definitions like this work by setting up rules that get applied automatically during calculations. For example, you can clear the definition of f and get the same outputs by applying rules using /dot. You can give definitions for specific cases. For example, these assignments give a definition for a function f when the argument is 1 and a definition when the argument is 2. This shows a use of those definitions. Any undefined cases are left unchanged. You can use /semicolon to restrict a definition to apply only when a particular condition is true. For example, this assignment sets up a definition that will apply to f of x and y only when x is bigger than y. And this shows an example of that rule being used. You can use question mark followed by the name of the function to see the definitions that have been set up for a function. For example, this shows the definitions that have been set up for f. The first two definitions were entered using immediate assignments with an equal sign, since the right sides of those definitions are just numbers, so there is no particular reason to delay those calculations. The last definition was entered as a delayed assignment with a colon before the equal sign, since the condition after the /semicolon can't be processed until the values of x and y are known, which doesn't happen until the definition is used. There are lots of ways to use patterns in function definitions. One interesting approach is illustrated by this definition, where the named patterns x and y are actually pieces within the arguments of the function f rather than entire arguments, which effectively uses patterns to destructure the arguments of a function, which is an alternative to a definition like this one, which gives the same result, but this definition does the destructuring on the right side of the definition rather than by taking advantage of what can be done with patterns. Another use of patterns is in defining functions that do different things for different types of arguments. The Wolfram language doesn't really have types, since everything is a symbolic expression, so everything has the same type, but the heads of expressions can be used as a kind of type designator. For example, this defines a function f that does one thing when the argument is an integer, and something else when the argument is a string. You can also effectively make up your own types this way. For example, if the function f needs to handle things of two different types, say u objects and v objects, you could treat symbolic expressions with a head of u as u objects and symbolic expressions with a head of v as v objects, and give different definitions like this for what f should do when applied to a u object or to a v object. And after that, of course, the definition that gets used will depend on the head of the argument. You can find more information about defining functions by selecting Wolfram Documentation under the Help menu to bring up the Documentation Center page, clicking on the Core Language Instructor button, and then selecting Variables and Functions, which brings up this page with links to related tutorials and to all of the operations covered in this section.